Greeting of the day. I am Kumar Parashari and I love doing physics. Today I am here with the solution of physics paper Neet 2020. Let's straight away start with the first question. And this question is from simple harmonic motion. And we have been asked to find the phase difference, between displacement and the acceleration. And the phase difference between the two can be found using this particular fact that in simple harmonic motion, if a particle starts its journey from mean position and towards the right side, then its displacement is given by x at t is equals to a sine omega t. Let's say this is relation number 1. Now differentiate it twice. We will get acceleration at time t is equals to minus omega square a into sine omega t. This is relation number 2. And relation number 2 can be rewritten as this is omega square a sine omega t plus pi. This is relation number 3. Just try to compare relation 1 and relation number 3. For the sake of simplicity, let's write x at t underneath it. This is a sine omega t. Now compare 1 and 3. You will notice that acceleration leads displacement in phase by pi by 2. Acceleration leads displacement in phase by pi. Is that right? So the answer is pi radians. They have asked the phase difference, but the correct statement would have been acceleration leads displacement in phase by pi. Now let's see. I'm leaving something for you as well. You should know under what condition you write x at t is equals to a sine omega t plus phi naught. Phi naught happens to be the initial phase, and initial phase will be 0 if particle starts its journey from the mean position and towards the right side. Let's come to the next question, and this is the next question. In the next question, we have been asked to find magnetic field at the center of the solenoid, and the magnetic field at the center of the solenoid or somewhere in the middle of the solenoid is given by mu naught Ni. And over here N stands for number of turns per unit length. Let's substitute values of all the given numbers. This is 4 pi is to 10 is to the power minus 7, and their turns, these 100 turns in 50 centimeter. So this is 100 turns 50 centimeter means 1 by 2 meters. Is that right? So this becomes number of turns per unit length. I am using SI unit only, so that is why this has been written in meters, and I happens to be 2.5 meters. Is that right? 2.5 amperes. Now we need to solve it. Now as we solve it, we will notice that 4 into 2.5, this is 10, and this 100, that becomes 1000. This is 2000 pi. This is 2000 pi is to 10 is to the power minus 7 Tesla, and this got to be 6.28 is to 10 is to the power minus 4 Tesla. So the fourth option is correct. Let's proceed with the next question. This is very much the standard problem. This is the Atwood machine, and the what have been asked, let's see, the acceleration of the system in terms of acceleration due to gravity. Okay, because this is the Atwood machine, so the acceleration will be given by, you can always use this formula for the case of Atwood machine. This is a standard, so I'm not deriving it. M1 plus M2 bracket is to G, and when you use, you should always remember that M1 is more than M2. Let's substitute these values. This is M1 and this is M2. So this is 6 minus 4 upon 6 plus 4 into G. Solution, this leads to G by 5. Is that right? So this is the correct answer. Now let's proceed with the next question. This is the next question. The ratio of the contribution made by the electric field and magnetic field component to the intensity of electromagnetic wave. You need to be slightly careful. So why I'm saying you need to be slightly careful? The ratio of we already know that the ratio of amplitude of electric field to the amplitude of magnetic field is equals to C. This happens to be the one of the property of electromagnetic waves, but over here they haven't asked this ratio, and had this been ratio, answer could have been C:1, I guess. But if you see carefully, the ratio of contribution made by electric and magnetic field component to the intensity of the electromagnetic wave, and intensity of a wave, this is equals to energy density into velocity of the wave, of course. And the energy density, let's talk about the electric component. If I talk about electric component, the energy density is equals to how much? Half epsilon naught E RMS square into C. Is it right? If you wish to write, I mean, you are welcome if you write this as 1 by 4 epsilon naught E naught square is to C. So this is intensity of contributed by the electric component of electromagnetic field. Is it right? And we are supposed to find the ratio of the contribution made by electric field and magnetic field component to intensity of electromagnetic wave. So this ratio of intensity due to electric component divided by magnetic component. Is it right? And this value on the left hand side, this value is 1 by 4 epsilon naught E naught square is to C, and this value is 1 by 4, and this term will be replaced by 1 by mu naught B naught square is to C. Is that right? But these two terms, these densities, this density and this density, they're equal, and C is always equal. So the expected answer is 1:1. This question is from electromagnetic waves, and we already know that energy per unit volume inside electric field is same as energy per unit volume inside magnetic field. Is that right? And you see this term, this is the energy stored per unit volume inside electric field, and this is also termed as the energy density. Is it right? So answer is 1:1. Let's come to the next question, and the next question is, in a certain region of a space with volume 0.2 meter cube, electric potential is found to be 5 volt throughout. So here is a region, this is the region in which the potential is constant. Potential is constant, I mean, this is important, and we already know that if we're talking about the variation of electric field in x direction. So this is given by minus dB by dx. Is it right? Now V being constant, and because V is constant, so this got to be 0 as V is equals to constant. So the magnitude of electric field within this region, at every point within this region, the electric field has to be 0. Now let's come to the next question. And this is the next question. This is again the straightforward question. The average thermal energy for a monochromatic gas is, because the monochromatic gas, so answer got to be 3 by 2 kVT. So the average thermal energy for the monoatomic gas molecule, this is equals to 3 by 2 kT. And you should always be knowing, and what should be for the diatomic molecule, what should be triatomic molecule, then you should also be knowing when these atom happens to be rigid or not. So do we need to consider the vibrational degree of freedom or not? Anyway, this was for the case of monatomic gas, so answer is 3 by 2 kT. This is pretty standard, straightforward. Now over here, if you see, we have been asked to find torque, and torque is given by the expression R cross F. And over here, R is equals to how much? 2K cap. And the value of this is 3J cap. And this is equals to 6 K cap cross J cap, and this is equals to minus 6 I cap. Newton meter got to be the answer. So this second option is correct. Now let's come to the next question. Again, it is a straightforward mean free path. Mean free path, this is a standard value, is the mean free path is given by mean free path is a standard relation. You should remember it. Derivation has been done in NCERT. See it carefully. Why root 2 is included in the derivation. This is what you should also be knowing. This is root 2 pi n d square. You should be knowing it. Derivation, I will discuss sometime if required. And the energy equivalent of the substance, we know that the energy equivalent of m kg of gas is given by mc square. And over here, this is 0.5 is to 10 is to the power minus 3 kg. And C is 3 is to 10 is to the power 8 meter per second whole square. Solve it. This is 0.5 is to 10 is to the power minus 3 is to 9 is to 10 is to the power 16. And this is equals to 4.5 is to 10 is to the power 13 joules. So the answer, first option, is correct. Let's come to the next question. This is related to screw gauge. Okay, the least count of screw gauge. This is given by pitch upon number of divisions. And over here, see, the least count is given to be 0.01 mm, and we have been asked to calculate pitch, and number of division happens to be 50 as per the problem. So the pitch is 0.5 mm. So second option is correct. Is that right? Let's come to the next problem. See, over here we have two cylinders A and B, equal capacity, connected to each other via a stopcock. Okay, so these are two cylinders A and B. These are connected via a stopcock. Is that right? So right now this is closed. All the gas is in ball A, and this ball B happens to be empty. This ball B happens to be empty. This is completely evacuated. The entire system is thermally insulated. Stop cork is suddenly opened. This stop cork is suddenly opened, and we are supposed to tell you the process. So the process cannot be isochoric. Why the process cannot be isochoric? Because you see, initially the volume in which the gas is V, now the volume now becomes 2V. So the volume, there is increment in volume, so and hence the process cannot be isochoric. And similarly, because the volume is increasing, so we cannot expect this to be isochoric either. Now we are left with two options, adiabatic and isothermal. Now you see, now when this gas expands while moving from ball A to ball B, then you see, I mean, there is nothing, I mean, in ball B to oppose incoming of the gas. As gas enters, there is nothing that will oppose entering of the gas. Is that right? So the work done, I mean, work done by the gas during this expansion process is zero. Work done during expansion is equals to zero. This is also called as the free expansion. Is that right? So this is work done is equals to zero. So further we know that work done is equals to zero. Okay, now because the work done is equals to zero, so we do not expect any change in temperature. So there is no change in temperature. No change in temperature. Now because there is no change in temperature, so delta U, change in internal energy, and CV delta T, this is equals to zero. Is that right? Now see, the change in internal energy is zero. Because change in internal energy is zero, there is no change in temperature, so the process got to be isothermal. Some of you might definitely expect why, because you see, if I take it this relation, delta U is equals to delta U plus delta W. This is zero, this is zero, so the energy is not escaping anywhere. This is thermally insulated, so this may confuse you that it could be an adiabatic process. But why this is not, I mean, why this is not an adiabatic process? Because you see, in adiabatic expansion, I mean, work is done at the expense of internal energy, and because there is no change in internal energy, and hence the process cannot be adiabatic. So this is isothermal. This is totally isothermal. Free expansion is an isothermal process. Is that right? So the option 4th is correct. Now let's come to the next problem. A cylinder contains hydrogen gas at pressure of 249 kilopascal and temperature this much. Density, we are supposed to find out the density. We see, because gas is filled in a container, so we can always write PV is equals to nRT. So this can further be rewritten as PV is equals to M by capital M RT. M is mass of the gas, capital M happens to be the molar mass, so P is equals to M by capital M capital V RT, and this capital M by capital V, this could be rewritten as rho, the density, by MRT. Is that right? So the density rho should be given by the relation PM by RT. Now substitute all the values carefully. Pressure is 249 is to 10 is to the power 3, and this is molar mass. Is that right? And the gas happens to be hydrogen. So this is 2 is to 10 is to the power minus 3. Please note that I have not written 2, and because you see, we are solving in MKS always. We will put always all SI units. Is that right? So this is 2 is to 10 is to the power minus 3. Otherwise, M happens to be how much? M happens to be 2 gram per mole. Is that right? So this is unit of capital M. So this gram is to be converted into kg. And this is 8.3 SI unit, and the value temperature 27 means this is 300. Is that right? Now see 8.3. 8.3, I mean, it seems they can be cancelled, these two. Is that right? How? Decimal, so multiplied by 10, ones-a, this is threes-a, these will be cancelled, 3 ones-a, this will be 100, this 0 will be cancelled by this 0, and this is 10. 10 means what? 10 means, I mean, see, this will cancel. 2 upon 10 is how much? 0.2. So this is 0.2 kg per meter cube. This should be the density. So option A is correct. Now let's come to the next question. This is pretty straightforward problem. I'm supposed to find out when the uranium isotope is bombarded with neutron, it generates this, then the 3 neutrons, and the missing element is to be found. This is a standard. Anyway, you can write this as directly, but anyway, we already know that neutron is bombarded upon uranium 92 235, and is already given. One of the component happens to be the krypton 3689. The missing component we are supposed to find, and there happens to be production of 3 neutrons. Let's try to have conservation of atomic number. This is 92, this is 36, this is 0, so this got to be 56. So it's a possibility, this is the only possibility. So this is barium. Is that right? And for further analysis, if you see, let's try to conserve the mass number as well. This is 236, and on the left hand side, on the right hand side, this is 89 and 3. 89 and 3, this is 92. 236 on the left hand side. So what is left? So what is left is 144. So 144, is that right? So 1 plus 235 is 236, 89 plus 144 plus 3, that will also make it 236. So this is how we arrive to this conclusion. It should be the barium. Now next, now we have been asked to find mobility. Is that right? And we know that drift velocity is directly proportional to electric field, and the constant of proportionality is called as the mobility. Is it right? And we have been asked to find mobility. Mobility is drift velocity per unit electric field. Let's substitute the values. So the drift velocity happens to be 7.5 is to 10 is to the power minus 4 upon what? This is 3 is to 10 is to the power minus 10. Solve it. Now as we solve it, this is 2.5 and this is 10 raised to the power. This is 10 raised to the power 6 plus 6. So this is equals to 2.5 is to 10 is to the power 6, and the unit we already know. This is meter square, volt inverse, second inverse. So the answer A is correct. Now let's proceed to the next problem, and we're supposed to subtract these two. So this is 9.99 minus 0.0099. We are supposed to subtract these two, taking consideration of rules of significant figures. So let's put 0. So this becomes how much? This becomes 1, this becomes 0, this becomes 8, 9.9. Now we are supposed to put this answer keeping consideration of the rules of significant figure. Now because we are subtracting two numbers, so the result can have as many significant figures as are in the measurement, which is accurate. I mean, you see this number, this number is accurate up to 2 decimal places, and this is accurate up to 4 decimal places. So answer cannot be accurate more than up to 2 decimal places. So we will round off these two, and what is left will be the answer. So the answer is 9.98 meters. So this A is the answer. you should be clear with the rules when we add or subtract, multiply or divide. Now next question is the iron rod susceptibility. Susceptibility is 599, and we know that relative permeability is given by 1 plus susceptibility, magnetic susceptibility. So that makes how much? This is 599 plus 1, this is 600. Is that okay? Permeability of the material. Permeability of the material, this is equals to mu r times mu naught, and this is equals to 600. So this is not required in the calculation. So this is 600, and this is 4 pi is to 10 is to the power minus 7. The calculation tells us this is 2400 pi is to 10 is to the power minus 4. So this is 2.4 pi is to 10 is to the power minus 4. This is 7. Is that right? And this is, you can always write unit Tesla, meter, ampere inverse. So which of the answer is correct? I guess this fourth option is correct. So the next problem is the spherical conductor. Okay, the spherical conductor has a radius. This is a spherical conductor. This has a radius capital R. Capital R is equals to 10 centimeter. And what is magnitude of electric field at a point 15 centimeter from the center of the sphere? So the point P that lies outside this sphere. Is that right? Because the point P lies outside this sphere. So the value of electric field, that should be equals to K Q by small r square. Substitute all those values. K is 9 is to 10 is to the power 9, and capital Q is equals to how much? Capital Q is 3.2 is to 10 is to the power minus 7, and the radius is how much? The spherical conductor and the distance is 15 centimeter. I need to write in meters. Is that right? So this is 0.15 multiplied by 0.15. So wanted to remind you that 9 by 4 is equals to 2.25, and 900 by 4 is equals to 225. So this could be used. Is that right? If you see carefully. So this is 9 is to 10 is to the power 9 multiplied by 3.2 is to 10 is to the power minus 7. Let's write 10 is to the power minus 4 so that we are free from these decimals. Is that right? Now this is 225. 225 can always be written as 900 divided by 4. Is that okay? So that will make calculation a little simpler. So 10 is to the power minus 3. Is that okay? So 9 ones are, this is 100, and 4 will go up upon 100 means 10 is the power minus 5, and this is 4 multiplied by 3.2 is to 10 is the power minus 5. So that makes it 1.28 is to 10 is the power minus 4 Newton per Coulomb. So I guess this answer is correct. Is it okay? Let's come to the next issue, next problem. In this problem, we have a LCR circuit connected to an AC voltage. L is removed. When L is removed, you have only RC circuit. Is that right? This is RC circuit to the AC source, and the phase difference, if theta happens to be the phase difference in this case, then tan theta is equals to, you see, this is XC by R, and the value of tan theta is this. Is that right? So tan 60 degree, this is root 3. This is root 3 is equals to XC by R. So XC is equals to root 3 times R. And let's see that what else has been given. If C is removed, from LCR, so you have only RL circuit. Is it right? So this is RL circuit connected to AC source. In this case, again, if theta happens to be the phase difference, then tan theta is equals to XL by R. And the phase difference is how much? Pi by 3. Pi by 3 means 10 pi by 3, 1060 means root 3. This is XL by R. So the XL is equals to root 3 times R. If you see carefully, XC and XL are same. If XL and XC are same, now what have been asked? The power factor of which circuit? LCR circuit. And in LCR circuit, what we notice, XL equals to XC equals to root 3 times R. Is it right? So the LCR is in resonance. So LCR circuit is in resonance. Because LCR circuit is in resonance, so we expect theta to be 0. The phase should be 0. Is that right? So current and voltage, they should be in same phase. So power factor this is equals to cos theta, and it should be equals to 1. Is that right? So second, this is the answer. Theta is equals to 0. Substitute this value to get 1. Now the next question. Here is capillary problem. The capillary tube of radius r is immersed in water. Water rises up to height h. Okay. So here is the capillary. When this is dipped, water rises to height h. The label is h. Is that right? And you see, in this case, if you could recollect, the upward force which pulls the water up, that is given by 2 pi r is to t cos theta, that holds weight mg. Mg is the weight of the liquid in the capillary above this level of the water. Is that right? Now next part, if you see carefully, that 2 pi r is to t cos theta is equals to mg, and in this case what has been done, when another capillary of radius 2r is immersed in the water. Now because the second capillary has been immersed, which has radius twice the previous capillary in the same water, we are assuming that theta is same, t is same, radius is doubled. Because the radius is doubled, so we expect, if we follow up, this should always be applicable whenever a capillary is immersed inside liquid. So as R is doubled, we expect mg should become 2 mg. Is it? So 2 mg means, so answer should be the amount of liquid that should be equals to how much? That should be 10 gram. 10 gram is the liquid that this capillary of twice the radius should be able to hold. Is that right? Now let's come to the next problem. In the next problem, this is Young's double slit experiment. Young's double slit experiment, you're already aware of all the related information. This is a screen, capital D. These are the two monochromatic sources for us. The separation is a small d. The fringe width is given by lambda capital D by a small d. And over here, if you see carefully, what has been done? Capital D is doubled. Separation is halved, and the distance is doubled. Capital D becomes 2d. A small d becomes d by 2. So we have 4 times lambda capital D by a small d. This is equals to 4 beta. So the fringe width should become 4 times. Now over here, this is A. A is the input of this NOT gate. So at this point, we should get A bar. B is the input of this NOT gate. So we should get B bar. Anyway, this also happens to be the standard circuit. You should be able to recollect all by yourself. So for this NOR gate, this is NOR gate. The inputs are A bar and B bar. So what this NOR gate does, does that Y is equals to, so it does OR operation for the inputs This is OR operation. It first, I mean, the inputs are A bar and B bar. So first it does the OR operation, and then NOR basically does OR plus NOT operation. For the OR operation, this is what we'll write, and for the NOT operation, we'll write like this. Now use the Kumar's rule, and this will be A bar bar plus A bar bar dot, plus will change to dot, and B bar bar. Is that right? So the Boolean expressions, I mean, you should be able to use these rules. And A bar bar itself is A and B bar bar is B. So basically this is an OR, this is an AND gate. Is that right? Effectively this combination, this whole combination should act as an AND gate. And for AND gate, what could be the appropriate table? I guess 4th is the appropriate table. 0 0 is 0, 0 1 is 0, 1 0 is 0, 1 1 is 1. So the 4th table is correct option for it. Is that right? And this is color code system. I mean, let's use this. BB Roy, Great Britain, very good wife. This B stand for black, start with 0, brown for 1, red for 2, orange for 3, yellow for 4, green for 5, this is 4. This is 6, this is 7, this is 8 and 9. Is it right? This G is for gray. So yellow is 4. So let's write this first 4, and this violet is 7, write 7. This is 4 and this is 7. Together you need to read this is 47. And brown appears as the power of 10. So brown is 1, is it? And gold is gives you tolerance. This is plus minus 5%. So this is 47 is to 10 plus minus 5%. This is 470 ohm plus minus 5%. So this is the answer. Is it okay? Let's come to the next problem. The capacitance of a parallel plate capacitor with air as medium is this. With the introduction of the dielectric, the capacitance becomes 30 microfarad. So C in C is equals to epsilon naught A by D, and in presence of medium, this is, you already know, this is K epsilon naught A by D. So this is equals to K times C, is it? And this is 30 microfarad. K we are supposed to find, and how much is C? This is 6 microfarad. So the dielectric constant of the medium which has been put in between the plates is 5. Is it okay? Let's see that what we have been asked to find. Permittivity of the medium. Permittivity of the medium, this is equals to relative permittivity into relative permittivity is to epsilon naught, and this relative permittivity is same as the dielectric constant is to epsilon naught. Multiply these two. This is 5 multiplied by 8.85 is to 10 is to the power minus 12. Solve it, will end up with the result 0.44 is to 10 is to the power minus 10 Coulomb square, Newton raised to the power minus 1, meter minus 2. So this is the answer. Let's come to the next problem. So here is the building. Read this problem carefully. The ball is thrown up with how much velocity? 20 meter per second. It goes up, then reaches at the bottom with how much velocity? This reaches at 80 meter per second. Is that right? In downward direction. Height of the tower. So height of the tower we are supposed to find. This is the height we are supposed to find. Let's see that. Let's apply third formula. Third formula is V square is equals to U square plus 2AS. See that how I really write it. This is minus 80 whole square. I'm considering this as positive direction. Automatically this will become negative direction. U is plus 20 whole square plus twice a is minus 10, because acceleration due to gravity, this is in downward direction, and displacement, this is initial, this is final position. Displacement is always from initial to final position, initial to final. This is displacement. Displacement is in downward direction. Is that right? Anyway, because we are supposed to find height of the tower, so let's write this as h. So I'm not using sign convention because this h happens to be the unknown quantity. Had this been known, we would have used the sign convention. This is a known value, this is also known value, this is also known value. We have used sign convention. H remains the unknown. So this is 6400, this is 400 plus 20h, so that makes 6000. This is equals to 20h. So the h is equals to how much? This is equals to 300 meters. So 300 meter is the answer for you. This is height of the tower above the ground. Is that right? Next part. A body weighs 72 Newton on the surface of Earth, and what is gravitational force on it at height equal to half the radius of Earth? We know that g on the surface and g at height h above the surface g dash. G dash is given by the relation g 1 plus h by re whole square, and in the problem h is equals to how much? Re by 2. So because h is r by 2, so this will become, given that h is equals to how much? Re by 2. So h by re is equals to how much? 1 by 2. This is what I have substituted. Solve it further. So this will become 4 g by 9 g dash. Now what you do, multiply both sides by small m. Mg dash is equals to 4 by 9 into mg. Now this mg becomes weight on Earth's surface. This will be weight at height h. So weight at height h, let's do it over here. This is 72, mg 72. So 8, and this is equals to 32 Newton. So first, this is the right answer. Is that right? Let's proceed with the next problem. In the problem, two particles 5 kg and 10 kg respectively are attached to the two ends of the rigid rod of length 1 meter and negligible mass. So here is the rod of negligible mass, and these are the two balls, and this is 5 kg and this is 10 kg. Now what you do is take this as origin, and try to find its center of mass. If the distance of center of mass from this origin is xcm, then xcm by definition is given by the value m1 x1 plus m2 x2 upon m1 plus m2. In the problem, m1 is 5, x1 is 0, m2 is 10, x2 is exactly 1 meter. Let's write in centimeter divided by 5 plus 10. So that becomes 10 is to 100 divided by 15. 5 2s are 5 3s are. So basically this is 200 by 3 centimeter, which is approximately same as 67 centimeters. So this is the correct option. Let's come to the next problem, and this is straightforward. In this problem, you see the width of depletion layer will increase only in reverse wise. So no other choice. This is totally subjective problem. So width of the depletion layer in a PN junction diode increases in reverse bias only. The next problem, you see the light of frequency 1.5 times the threshold frequency. Let threshold frequency be nu naught. This is threshold frequency, and here is the photosensitive material. Is that right? This is photosensitive material. Threshold frequency is nu naught, and the incident light happens to be of 1.5 times nu naught. So light of frequency 1.5 times the threshold frequency is incident on a photosensitive material, so we understand it. Next, what will be photoelectric current if frequency is halved? If frequency is halved, then what will happen? If frequency is halved, in that case, in the second case, this will be equals to how much? 0.75 times nu naught. So incident frequency for this case, the incident frequency is less than the threshold frequency, so the photoelectric effect will not take place. Photoelectric effect does not take place, so photoelectric current will be 0. Let's come to the next problem. Assume that the light of wavelength 100 nanometer is coming from a star. The limit of resolution, this is inverse of resolving power, and resolving power of telescope is equals to how much? Diameter upon 1.22 lambda. Is it right? And the limit of resolution delta theta, this is inverse of resolving power, and this should be equals to 1.22 lambda by d. Now substitute values. This is 1.22 is to 6000 is to 10 is to the power minus 9 divided by 2 meters. Is that right? So 2 ones are, this is equals to 0.61. let's take it 6 only. 6 is how much? This is 0.6. 0.6 means you can always cancel 0, so this is 360 is to 10 is to the power minus 9, so this is 3.6 is to 10 is to the power minus 7 radians. So that should be the limit of resolution. So this fourth appears to be the correct option. Now the next, now this resistance wire connected. So here is a meter bridge. This is a meter bridge problem. So in the meter bridge problem, so what exactly has been given? Let's see. This is left gap and this is right gap. So in the left gap, a resistance wire connected in the left gap of a meter bridge balances. Over here a wire is connected. Is it right? Though this wire is connected in the left gap. A resistance wire connected in the left gap of a meter bridge balance. Left gap of meter bridge balances a 10 ohm resistance in the right gap. So over here is a 10 ohm resistance in the right gap, which divides the meter wire in the ratio 3:2. So this wire is divided in two parts, 3x and 2x. If the length of the resistance wire is 1.5 meter, so this is the resistance wire, then the length of 1 ohm of the resistance wire is, okay, so first point is this meter bridge is balanced. So can we write this as R by 10 is equals to 3 by 2. So R is equals to how much? 15 ohm. So this is 15 ohm. Now 15 ohm is resistance of what? 1.5 meter. 15 ohm is resistance of 1.5 meter. So 1 ohm will have how much length? 1.5 meter upon 15, and this is equals to 0.1 meter. So we have been asked, that what is the length, what should be the length of a wire which has 1 ohm resistance? Is that right? And answer is equals to how much? And answer is 0.1 ohm. Now next part, let's look at this problem. Light of average flux of 20 watt per centimeter square falls on a non-reflecting surface. Let's try to understand what this term stands for. 20 watt per centimeter square, and this is 20 joule per second into centimeter square. So basically this becomes energy per unit area per unit time. Is that right? And energy per unit area per unit time is nothing but the intensity. And intensity effectively is same as energy density. Energy density multiplied by energy density multiplied by the velocity, as we have already done this part. Is that right? And how much is the energy density? If you're interested, this is equals to epsilon naught is to E naught square half. Is that right? Into C. You need to wait how this term is written. You need to go through, in fact, this chapter electromagnetic waves will come to know. So the intensity of the electromagnetic wave is given by this expression. This gives you energy per unit area per unit time. Is that right? This value is already given. So whatever energy is incident, that is absorbed because the surface happens to be non-reflecting. Achha, so this is energy incident on unit area in unit time. So if you multiply it by this number and this number, so what you should get? Energy incident. So energy incident on 20 centimeter square area in 60 seconds. That should be equals to how much? Energy incident per unit area per unit time multiplied by area multiplied by time. Is that right? And this number, you see, this number is given to be how much? This is given to be 20 joule per centimeter square into second, and area happens to be 20 centimeter square, and this is equals to 60 seconds. If you multiply all that, you will end up with the result how much? You see, first the unit centimeter square will cancel, second and second will cancel, and this is equals to 20 multiplied by 20 multiplied by 60. This got to be equals to 24 is to 10 is to the power 3 joules. So the correct answer is this. Now let's come to the next problem. So in this problem, a ray of light is incident at an angle of incidence I on a surface of a small angle prism. Okay, and the prism angle is A, emerges normally from the opposite surface. So here is a prism, and thin prism, in fact. So light is incident, it will suffer refraction. After refraction from surface AB, it lands up on AC surface normally. Now, because it lands up on AC surface normally, so it will move as it is. Is it right? Without deviation. There is refraction, but there is no deviation as such. At this point R2 is equals to 0. R2 is equals to 0. We already know that R1 plus R2 is equals to A, and R2 is equals to 0 means R1 is equals to A. So let's choose this point to be point P. So apply Snell's law at point P. Now, as you apply it, light is traveling from air to the medium. So I should be writing 1 is to sine I. I happens to be angle of incidence. I happens to be angle of incidence. So the angle of incidence, this is angle of incidence. Is that right? So next part. So this should be written as mu times sine R1. At this point, the angle of refraction is R1. Is it okay? So this angle is R1, you're already aware of, but R1 is equals to A. So this is mu into sine A. Sine I is equals to mu times sine A. But over here, we're considering prism with a small prism angle. So this is a thin prism. For a thin prism, A is a small, I is also taken to be small. So we'll end up with the result I is equals to mu times A. For small angles, sine theta happens to be equals to theta. Is that okay? So then angle of incidence is nearly equals to how much? Mu is to A. So this is the correct option. The next part. So here is a capacitor connected to 200 volt 50 hertz supply, the RMS value of current. So IRMS, this should be equals to VRMS upon XC, the capacitive reactance. And VRMS, this is 200 volts, and this is equals to 1 by, let's write it this is separately, this is equals to 2 pi nu into C, and this is equals to 1 by 2 pi, let's keep pi to be same as pi right now, this is 50, and C is equals to how much? C happens to be 40 is to 10 is to the power minus 6. Now over here, the product is how much? 2 is to 50 is 100, and then 100 and then 40. So this is 4000. So this is 1 divided by 100 is to 4000 pi is to 10 is to the power minus 6. Substitute this value. So this is 1 divided by, so it will go up, this is 4000 pi is to 10 is to the power minus 6, and you see over here 1 2 3 4 5, so that makes 10 is to the power minus 1. Is that right? So what else is left? We are left with 2 is to 4 is to 3.14 is to 10 is to the power minus 1. So this is 8 multiplied by 3.14. So let's make it only 3.1. So this is 8 and this is 24. Is that right? So this is 2.48 amperes. So the correct answer should be 2.5 amperes. Next part is stress should have dimension same as pressure. So the correct answer is third. I should not be going into these details. And the Brewster's angle, you know, as per the Brewster's law, if theta p happens to be the Brewster's angle, so tan theta p is equals to mu. Is it okay? But you see, mu is always greater than 1. Mu is always greater than 1. Light ray in this case, you know, this is traveling from rarer to the denser medium, one medium to another medium. Is that right? So mu is always greater than 1. Greater than 1 means what? Now you see, if this happens to be, mu happens to be greater than 1, so theta p should be greater than 45 degree. I should write, could have written tan theta p greater than 1. This implies that theta p is greater than 45. So the value of theta p that should lie between that should lie between 45 degree and 90 degree. It should be more than 45 but less than definitely 90 degrees. So the correct answer, this is the correct answer. So the next part. So this is simply the Young's modulus formula for when a wire is hanged. So over here we have a wire which is hanged with a rigid support, and we place a weight at its lower end. Is it right? This is mg. So the Young's modulus is given by mg by a is stress upon strain delta x by x. Now over here this is mg by a delta L. This is change in length. So this is final length minus initial length, and this x is same as the original length. So I expect this should be the correct answer. Let's come to the next problem. This is an electric dipole with dipole moment. Dipole moment is given, distance is given, and angle is given. So here is a dipole, minus q plus q. Midpoint of dipole is always chosen as origin, and here is point P at a distance r making angle theta. The electric potential at this point is given by, kp cos theta by r square. Let's substitute the values. So this is 9 is to 10 is to the power 9, and p is 16 is to 10 is to the power minus 9, and cos theta, this is 60. Cos 60 is how much? This is half divided by distance. Distance is how much? 0.6. So this is 0.6 multiplied by 0.6. This is the expression of electric potential at a point due to a short dipole. Is that right? You solve it, and now as you solve it, decimal and this decimal, that will make it 100. Is it right? And 9 ones are 9 fours are 36, and then this 2 will come in the denominator, that will make it 8. 8 2s are 16, minus 9 plus 9 will cancel 2. This becomes 200 volts. So this is the correct answer. Now let us attempt this problem. In a guitar, the two strings, string A and string B, made up of same material and are slightly out of tune and produce beats of frequency 6 Hz. And also given the frequency of A is 530. So case first, string A, string B, and this frequency is given 530 Hz. The choice, it could be case 1, it should be 524 Hz. Is it right? So the frequency, when string A and string B, they are plugged together, then 6 beats should be produced. Is that right? And another case 2, this is A, this is B. A has frequency 530 Hz is already given. The B can have 536 Hz. Is that right? So in either of the case, the beat frequency is 6 Hz. Is that right? Now what has been done? So what has been done? The tension in the B is slightly decreased. If tension in B is slightly decreased, and we already know that nu is proportional to root T. If tension is decreased, then the frequency should also decrease, and this has been done for the string B. So this is a string B. The frequency, the tension has been decreased, frequency should decrease. If frequency decreases, let's write, it could have been the new values, let us write, it could be 523, 522, 521, 520. So it will remain 530. If you could see, initially it was 6 Hz beat frequency. Now it is 7 Hz, 8 Hz, 9 Hz, and so on. So as such, if frequency, if the tension of B is decreased, so definitely beat frequency can be 7 hertz, which has been which is given in the question. So to me, so case A appears to be right. The frequency, it should be 524 hertz. But nonetheless, let's try to discuss case B as well. Now in this case, the frequency of string B is 536 and the beat frequency is how much? Is 6 hertz. If the tension is decreased, if tension of string B is decreased, so its frequency should decrease. So the possible values could be 535, 534, 533 and so on. If you could see that initially the beat frequency is how much? Is 6. Now it has become 5. It has reduced to 5, then reduces to 4, then reduces to 3, then in this case 532, then 531, then 530. So the beat frequency is decreasing. It decreases to 0. And if tension is reduced further, then what will happen? In that case, it will keep reducing. 529, 528, 527, 526, 525 and 524. And when the frequency has reduced to 524, again the beat frequency heard will be 6 hertz. So in case 2, when the tension is decreased, first beat frequency decreases, then again increases to 6. Is it right? So in both the cases, frequency increases to 7 is possible. Possible 523. So the frequency can increase to 7 in both the cases. But it is clearly mentioned that tension is B is slightly decreased, because it's slightly decreased. So out of the two cases, this 524 appears to be the correct option. And for B, case B to be correct, the tension in the string should be decreased significantly compared to this. Now let's come to another problem. In this case, this is electron is accelerated, talking about de Broglie wavelength. And de Broglie wavelength, this is given by 12.27 by root V angstrom. Is it right? And the de Broglie wave in this case is given to be how much? 1.227 is to 10 is to the power minus 2 is to 10 is to the power minus 9 equals to 12.27 by root V is to 10 is to the power minus 10. Solve it, will get 10 is to the power 4 volts. Is it right? So this option is correct. Now let's come to this part. The solids which have the negative temperature coefficient, both insulators and semiconductors, they have negative coefficient of resistance. When temperature increases, the resistance of semiconductor decreases and also that of insulator decreases. So both insulator and semiconductors have negative temperature coefficient of resistance. Let's come to the next problem. The energy required to break one bond of DNA is this, value in electron volt. So what you should remember that 1.1 divided by 1.6 is equals to how much? This is equals to 0.625. Is it okay? Let's proceed. So over here 10 is to the power minus 20 joule. This is equals to 10 is to the power minus 20 divided by 1.6 is to 10 is to the power minus 19 electron volt. Now as you solve it, so you will have how much? This is 1 divided by 1.6 is to 10 is to the power minus 1. So this is 0.06 electron volt. So second is the correct option. Let's come to the next problem. Heat required to raise temperature of two solid copper spheres. And you see, amount of heat required to change the temperature from T1 to T2 is given by mc delta T. and this is equals to 4 by 3 pi r cube c delta t. All terms, they have the usual meaning. Now over here, the two spheres, radius r1 and radius r2, and r1 is equals to how much? R1 is equals to 1.5 times r2. This sphere is slightly bigger than this. Is it okay? And the rise in temperature in the both cases 1 Kelvin. So delta T is same for both. Delta T is same for both. Both are copper. So specific heat is also same. So delta Q1 by delta Q2, that should be equals to R1Q by R2Q. So R1 by R2 is equals to 3 by 2. And this is equals to 3 by 2 whole cube, and this is equals to 27 by 8. Is it okay? So this should be ratio of heat supplied to these spheres, so that rise in temperature in both the sphere is same. Is it right? This is ratio of heat supplied to these two spheres to ensure that rise in temperature in both is same. Let's come to the next problem. Which of the following graph represents variation in resistivity in temperature? We know that with increase in temperature, the resistivity increases for the case of metals. Is that right? So the two possible options are in this and these are the two options in which with the increase in temperature, resistivity increases. And if we choose T to be a small range, then this is perfectly okay, and you have been using it. Rho at temperature T is equals to rho at temperature 0, 1 plus alpha T. Is it okay? So this is a perfectly straight line having some intercept which can be obtained right from here. Is it okay? But if you're considering T to be of long range, then definitely I'll pick up second as the correct option. This is for the small range, and this is if you choose T to be of longer range. The next problem is the transistor action. For the case of transistor action, so just go through, we'll see the base region must be very thin and lightly doped. So this appears to be the correct option, and all these are incorrect. The last problem is that the Bohr's model is not valid. Bohr's model is valid only for hydrogen and hydrogen-like. So because it is applicable for hydrogen and hydrogen-like, so obviously this is all okay. This is deuterium atom. Hydrogen, so should be applicable for hydrogen atom, should be applicable for deuterium atom, should also be applicable for singly ionized helium atom. So the Bohr's model is applicable as long as you have one electron revolving around a nucleus. Is that right? Only one electron. So these are the possible cases. It will not be applicable for the ionized neon atom. Think of why? Because in this case you have more number of electron revolving around the nucleus. Is that okay? So thank you so very much. For more videos like this, I suggest that you should be subscribing this channel of mine, so you keep getting more and more notifications. Thank you.